Have you ever looked up at the night sky and wondered how big the moon is? Or maybe you looked up and just kind of wondered to yourself, how far away is the moon? Well, I'm Brett Bailey. We're going to discover the answers to those questions and many more coming up on Our Night Sky. I guess, of course, we should probably discuss first where the moon came from. Well, scientists have good reason to believe that about 4.5 billion years ago, a near-Mars-sized asteroid called Trojan, its actual name was Theia, slammed into the Earth, knocking a bunch of the Earth's material out into orbit, where it eventually congealed down into the ball that we look up and see as the moon. Studies from moon samples brought back by the Apollo missions tend to prove this out. The moon is made largely of the same material the Earth is. So now to answer the first two questions, how big is the moon? It's not very big at all. It would actually fit right on top of a map of North America with room left over. The moon is only 3,474 kilometers in diameter, and that is exactly the distance between Ottawa, Ontario in Canada and Vancouver, BC. And if we have any American viewers, that works out to be the exact distance between New York City and Phoenix, Arizona. So if you can imagine those two places, you'll see that the moon is not really that very big at all. It has about 1/4 the diameter of our Earth. Now, how far away is it? But it's only about 370,000 kilometers away. And if you remember that the moon travels around the Earth in an ellipse, its perigee is its closest point to the Earth, and its apogee is its furthest point to the Earth. And that's the reason why sometimes the moon will seem to be larger and bigger during a phase called the supermoon, because it is actually closer. And as it goes farther away, and its apogee is referred to as being a micromoon. Now, the distance between the Earth and the moon at its apogee is about just a little over 400,000 kilometers. If you took the diameters of all the planets in our solar system, Mercury, Venus, not Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and included Pluto, a dwarf planet, if you took in total all those diameters up, they would all fit in between the Earth and the moon when it's at its apogee and still have several thousand kilometers left over. So the ancients who were observing the moon, they looked at it and they tried their best to understand what was going on up there. And one of the things they did was they took a look at the dark areas of the moon and they thought of them as being seas that divided the land masses and so on and so forth. The bright areas were the land masses that they were looking at. So they were identifying things on the moon and imagining them to be things that they were familiar with here on Earth. Well, on a good night, when the sky was clear, they could look up and easily make out one of the larger craters. We can know it now as the Tycho crater. It's in the southeastern hemisphere of the moon, and it has long white rays that come out of it, and they go 1,000, 1,500 kilometers in all directions. And that's the ejecta that came out of the crater site when whatever meteor or asteroid hit it and made that impact. And astronomers believe that that crater is around 108 million years old, and all the features are still there. And the simple reason for that, we're going to take a look at some craters here on Earth. They're both from Quebec, one not too far north of the St. Lawrence River, and the other one way up the Ungava Peninsula. And you can see that they look totally different than the craters on the moon. As you know, the Earth has got weather, we've got an atmosphere, we have rains, we have seasonal changes, we also have tectonic activity, earthquakes and volcanoes, and so on and so forth that don't exist on the moon anymore, but at one time might have. So the craters on the moon are as old as the ones we have here on Earth, and we both have some that are fairly recent as well. They could look at the craters and not quite understand what they were. There are other features on the moon that we can't see until we get looking through our our telescopes. And there are mountain ridges up there, long curving mountain range. There will be cracks in the surface of the moon, and rills and vales or valleys, and all kinds of wonderful things to take a look at. And I encourage you, if you get a chance, to look at sources like APOD and NASA. So the moon rotates around the Earth once every 27.3 days. It also spins on its own axis, counterclockwise, once every 27.3 days. Others have identified that as being a synchronous orbit, meaning that the same side of the moon is always facing the Earth. So how does that explain the phases of the moon? Well, it doesn't really. The phases of the moon are based on how much moonlight is reflecting off the moon's surface from the sun and meeting us. But as it rotates around the Earth, we only see a portion of that illuminated surface at a time. Once every 27 days, we'll see a full moon where the entire face of the moon is reflecting sunlight back to us. But as it continues off, that starts to change incrementally until you get to the first quarter, or as we know it as a half moon, all the way through to where it develops into a new moon, where it's totally blocked out between us and the sun, and it's dark, and we have a very, very difficult time seeing it. Sometimes we can see it from the Earth light reflecting off of the Earth onto the dark side of the moon, but generally, once it's gone, it's gone. You'll see the last crescent, then eventually you'll slip out of that phase, and you'll see a new crescent forming on the other side of the moon, and it'll eventually get larger and larger and larger as it orbits back around the other side of the Earth, back to a full moon phase again. Okay, so a little while ago we talked about just how big the moon is. Well, it's the 5th largest moon in our solar system. Number 4 is Io, one of the moons of Jupiter. Number 3 is Callisto, also a moon of Jupiter. Number 2 is Titan, which is one of Saturn's moons. And the largest of them all is Ganymede, again from Jupiter. So there's the top 5. So the next thing we need to talk about then are the eclipses that we can see. And there are 2. And the moon figures prominently in both of them, so it's well worthwhile discussing while we're talking about the moon. The first one is a solar eclipse, and the last one I saw was about 3 years ago. It rose just off the point of land behind me there, very early in the morning. The sun came up first, and it actually brought the moon up with it. And the moon had covered about half the sun by the time they broke the horizon. An eclipse can last a matter of minutes to maybe a couple of hours, depending on some factors. How far away the moon is from the Earth, and that'll make it smaller, so it won't be able to cover as much of the sun as it can if we had a supermoon happening, in which case it would pretty much block out the entire sun. But they don't last very long because the planets are constantly moving away from each other. This is an eclipse of the moon, and as you can look at the moon any time, you can enjoy watching an eclipse. A solar eclipse, on the other hand, is quite dangerous. It is the same as trying to look at the sun at high noon. It is so bright it will damage your eyesight. We'll discuss both eclipses in this episode because the moon plays a significant role in both events. We've talked about the ellipse of the moon around the Earth, but we did not mention that the moon does so with a 5-degree tilt to the plane of its orbit. That's critical in order for us to see a full moon. Without that tilt, we wouldn't see a full moon at all, only a monthly eclipse. When an eclipse of the moon occurs, the Earth passes between the sun and the moon. If the alignment is correct, this will cause the shadow of the Earth to pass over the moon. If the eclipse is penumbral, we will see a portion of the moon darken slightly in a reddish color. This part of the shadow is called a penumbra. This is because most of the sunlight is diverted around the moon, but the red of the spectrum refracts back behind the moon, casting a red shadow over it. Within that red cone is a much darker section called the umbra, which narrows the closer it gets to the surface of the moon. Only rarely will the umbra cone be large enough to actually be seen on the surface, but the whole moon will take on a total red color, earning the name blood moon. So this is the difference between the moon's phases taking nearly a month to complete, whereas an eclipse may last only a few hours. But the moon does change color. Thank you for stopping by and watching our first episode of Our Night Sky. For your information, most of the moon photographs, in fact all of the moon photographs that you saw today, were photographed by one of these two telescopes. This one is a 4-inch Celestron Exploroscope, a 114 AZ, which is a 4-inch reflecting mirror in the back here, projecting an image back up to the eyepiece at the front of the telescope. This one that is slightly larger is an 8-inch telescope, and it's got a large 8-inch mirror at the back, but it's a slightly different design than this one, where the eyepiece is at the back. So the image I'm looking at comes through the front of the telescope, reflects off a mirror, back up to a prism at the front, and reflects back down through the eyepiece. This is the one I took the close-up photographs of the moon, the seas and the craters. This one took the whole moon in smaller photographs. A lot of the photographs that you saw were borrowed from the NASA websites, whether it might have been APOD, Astronomical Photograph of the Day, directly from NASA themselves, or Hubble telescopes. And NASA includes on all their photographs links to whether or not the photographs are license required or if they're copywritten. Well, because I was in kind of a rush to use up as many photographs as I could, I didn't have time to email a lot of the original photographers. I just used what were available by iPod and NASA for use. And I highly recommend, if anybody needs to get some background photographs for a project they're working, as long as it's for educational purposes, it's not for profit, POD. APOD is an acronym for Astronomical Photograph of the Day, and every day a new picture is posted. And I can remember when I first started watching it, their archives went back about 10 years. Now they only go back about 5 years, but you can still do searches for anything that you want to see that you haven't seen yet in the first 5 years that you've been looking at it. And it's just a phenomenal site, and the stuff that Hubble's been taking are pretty tremendous. And I highly recommend that you take a look at NASA and APOD, and even the Hubble website as well. The pictures will just knock you out. So I hope you enjoyed the episode today, and I'm working on, right now, our next episode, which should be out in about another week or so, depending on how my production goes. And it's going to be about the space race. From the time that the Americans first started launching their Mercury 1 through the Gemini program, and into the Apollo program, where they finally landed men on the moon during Apollo 11. So I hope you stay tuned and watch for that. It should be up briefly. And thank you for coming by. Stay healthy, stay safe, and be good to your neighbors. Thank you.